Hello, so in today's video, we're going to look at the definitions of cosec, sec, and cot. So secant, the secant function, the cosecant function, and the cotangent function. So we're going to look at what these functions mean. So you may have seen like these words, these letters before. So the definition of cosec of x. So cosec of x is actually 1 divided by sine x. That's what cosec is. It's just 1 divided by sine x. Sec is actually 1 divided by cos x. And cosec is 1 over sine, sec is 1 over cos x, and cotangent, that's actually cos x divided by sine x. So that's what cot is. So if you think about maybe like a right angle triangle, for example, sorry, let me move it. Let me move it over here actually to that. So if we think about like a right angle triangle, yeah, so we've got a right angle triangle like this. We've got an angle there, let's call that the angle x, hypotenuse there, opposite there, adjacent there. So cosec you can think of as basically your hypotenuse over your opposite. So 1 over sine would be 1 over opposite over hypotenuse, which is hypotenuse over opposite. So you can think about it like that on a right angle triangle. And you can think about your your sec, your 1 over cos, as your hypotenuse over your adjacent. So that's what sec is. And you can think about your cot as your adjacent over your opposite side instead. So adjacent over opposite. So I mean, a quick way you can remember the like the first two, the cosec and the sec. This is how I remember the definitions. If you look at the third letter in cosec, the third letter is an S, and sin starts with an S. So if you look at your third letter, it is an S, sin starts with S. So that's how I remember that one. And then your third letter of sec, again, you just go to your third letters basically, and you get a C there, and your first letter of cos is obviously C. So sec corresponds to 1 over cos, and cosec corresponds to 1 over sin. So that's kind of how I remember those two. And cot, I mean, the third letter there is T. So you may be wondering, why is cot x not 1 over tan? Isn't this fraction there 1 over tan? Because we know, or maybe you may have not seen this before, but you probably have seen before, because I think we've mentioned it before in previous videos, that tan x is actually the same as sin x over cos x, which is true. So you may be thinking, so does this mean that cot x, which is the same as, so this is the real definition you need to know, that cos x is cos over sin. So you may be thinking, is cos over sin the same as 1 over tan? So in most cases, yes, it is exactly the same. However, there are some specific cases of x, some specific numbers that you substitute into these functions that actually this wouldn't work for, and we'll go through that now. So if we think about a y equals tan x graph, so y equals tan x, you've got these asymptotes, haven't you? You've got these asymptotes at pi over 2, at 3 pi over 2, 3 pi over 2. So like these odd multiples of pi over 2, so 5 pi over 2, and so on and so on. So like these odd number multiples of pi over 2, 1, 3, 5, 7, 9, and -1, -3, -5, and so on and so on. These odd multiples of pi over 2, you do get these asymptotes. So basically we know that tan of x, tan of pi over 2, or actually, let me write it like this instead. So odd numbers we can say as write it as 2n plus 1, can't we? So remember, using our proof, the proof videos that we looked at, the proof questions, remember 2n plus 1 can be said to be an odd number. So if we do 2n plus 1 times by pi over 2, when n is an integer, then this tan is undefined because we get these asymptotes. So this is all undefined. So for example, tan of 90 degrees to pi over 2, that's undefined. Tan of 3 pi over 2, that's undefined, and so on and so on and so on. So these are all undefined. Now so that means that therefore, if that's undefined, then 1 over tan is certainly undefined. So it's certainly undefined at those values there. So therefore, 1 over this tan of these odd numbers times by pi over 2, well, that must also be undefined as well. So now let's think about what happens when you do cos of, let's just pick pi over 2 to make the problem easier. So let's do cos pi over 2 divided by, so that's our tan, but let's now do cos pi over 2 divided by sin pi over 2. So cos pi over 2 is cos 90 degrees, which is 0, and then sin pi over 2 is sin 90, which is 1, so you get 0. So tan, so 1 over tan pi over 2, so again, this is 1 over tan pi over 2 here. So 1 over tan pi over 2 is not defined, but cos pi over 2 divided by sin pi over 2 is actually defined, it's actually 0. So that means that even though sine x divided by cos x always equals tan x, 1 over tan x doesn't always equal, so it doesn't always equal the reciprocal of sin over cos, which is cos over sine. So it doesn't always equal cos over sine, and we just showed that here. So when you substitute these odd multiples of pi over 2 into cos over sine and into 1 over tan, you get an undefined 1 over tan, but you get 0 for cos over sin. So actually, yeah, these functions are not exactly the same thing. So apart from those odd multiples of pi over 2, yeah, these functions are the same. But otherwise, no, these functions are actually going to be different when you do have like these odd multiples of pi over 2. So that means that therefore cos x over sine x does equal 1 over tan x only when x does not equal pi over 2 times by an odd number. So when x does not equal that, then yes, this is true. And because we know that sin over cos is tan, flip the fraction on the left-hand side upside down, you get cos over sine. Flip the tan upside down, you get 1 over tan. So yeah, it is true, but only when x does not equal pi over 2 times by an odd number. So what I'm trying to say then is, if we go back here, is that, yeah, so cot is actually defined to be cos over sine. So that's the definition you need to know. But yes, this does equal to, it is equal to 1 over tan. It's equal to 1 over tan when x does not equal pi over 2 times by an odd number, where n is some integer, any random whole number. So yeah, so again, you can kind of use again this third letter trick. So the third letter of cos is t, and t stands for tan. You can kind of use that, but just be careful. If x is equal to pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, or minus 1 pi over 2, minus 3 pi over 2, minus 7 pi over 2, then that means that actually cos over sin is not the same as 1 over tan. So we just want to be careful with that. So yeah, that's just a summary of what COSEC, SEC, and COT mean, and they're just definitions that you have to learn for your exams.